Hello, my dear student. I'm Mr. Kitwala from Educators. I will be with you in physics for Form 5. And today we are going to proceed with our discussion on our topic of rotation of rigid boats for our subtopic, the axis theorem of a rotating boat. So before we proceed with our discussion now, we are supposed to remember where we ended on the last session. On the last session, we tried to discuss about the perpendicular axis theory. We tried to know how can we state that law, and after there, we come up and look we tried to look on how we can demonstrate that the moment of inertia along to the axis must be equals to the moment of inertia along to the x-axis, then we add by the moment of inertia along to the y-axis. That is what we tried to see on the last session. But for our today discussion here, we are going to see some examples related with the perpendicular axis theorems. Our example number 4.7, this is the example number 7 for our first topic. And our example said that the moment of inertia of a uniform circular disk of mass m and radius r about an axis passing through its center and perpendicular to its plane is equal to the fraction. It means equals to 1 over 2 mr square. Now we are supposed to find the moment of inertia of the disk about the moment of inertia of the disk about any diameter. So first of all, let us try to summarize our given question here. And as we see, our question say that imagine we have the uniform circular disk, and that uniform circular disk having the mass m and also the radius r, and it is trying to rotate about an axis through the center and perpendicular to its plane, where the moment of inertia is given by a half mr square, as we try to observe here. Now, how can we obtain the moment of inertia of the disk about Roman 1 any diameter, and also Roman Roman 2 here, an axis passing through a point on the edge of the disk and also that perpendicular to the disk, and also at a tangent in the plane of the disk. That is what we are going to try to demonstrate on our question here. First of all, we should understand how can we obtain the moment of inertia, the formula of the moment of inertia for the uniform circular disk. Je, formula yake inasemaje? Lazima tuweze kuielewa, hapo ndo tutakuwa na uwezo wa kuweza kusolve swali letu. Hivyo, how can we get the moment of inertia for the uniform circular disk? And we say that moment of inertia for the uniform circular disk is given by a half mr square. That is, we tried to demonstrate on our past lecture. We say that mi is equal to mr square divided by 2. So for any diameter, how can we get the moment of inertia for the disk? And also for any axis passing through a center on the edge of the disk and the perpendicular of the disk, how can we get the moment of inertia? That is what we are going to try to demonstrate. Also for a tangent with the plane of the disk, tunapataje moment of inertia? So the plane, as we see our solution here, we have two figures. We have the figure Roman A, figure Roman B, and also the figure Roman C. So the plane of the disk is the xy plane as in shown in the figure. Kwa kama tunavyoona plane zetu hizi sasa ni plane ambazo zinatupatia axis mbili. It means we have xy plane. We have one of them is the y plane and also the x plane. And also for the second figure, we have similar with this one. also for the third figure are similar with Roman A and also Roman B. So on Roman A here, we have the circular disk. And this circular disk involves two coordinates or two planes, as we try to see. We have the y plane and also we have the x plane. And also we have the axis where the rotation tried to start. As we see that the circular disk are trying to rotate on it is an axis about the z axis, as we try to observe. And also for Roman B here, we have our circular disk, which is originated at the center of these two x planes. It tries to rotate perpendicular to each other. Kwa tuashumu kwamba ni kama tuashumu labda ni kama kijumba fulani kimetengenezwa alafu kikaning'inizwa kamba kwa juu, kwamba kinamna kinapokuwa kinajaribu kurotate on it is an axis there. So here we have the radius, that the distance from the center here, the perpendicular distance of this xy plane must be represented equals to r. Kwa ile distance ya kutoka hapa kwenye center mpaka kwenye ile AB, it means the parallel axis ambayo ni AB must be equals to r. And also this C represent the center. It means here pena represent the center of the uniform circular disk. And also, my dear student, at point D here, this represent the point of the circular disk. It means that the point of the circular disk equals to this one. So, my dear student, after here, we were supposed to try. We know that this plane here, it is tried to be changed. Kama tunavyoona kwamba ilivyokuwa na rotate, kwa mara ya kwanza ilikuwa kama kawaida, ilikuwa along z, lakini ilipozunguka ikatengeneza kwamba along to the vertical axis ikabini allocated z kama tunavyojaribu ku observe, lakini along to this axis we have the y, as we try to see here. But for C here, for the figure Roman C, we try to see that this C involve the axis. It means the parallel axis, which is EF. And this EF is originated or is located at any point of the circular disk, as we try to see. But we have the center similar with this one, and also we have the radius. It means the distance from the center up to the parallel axis, as we try to observe here. This D is any point of the cycle, the distance from C up to D represented by R, my dear students. So after this one, after observing our figures here, the figure Roman A, figure Roman B, and also figure Roman C, now let us go and see how can we get the moment of inertia related with our figure Roman A and also our figure Roman B, finally our figure Roman C. How can we get the moment of inertia, any diameter, and also on Roman 2 we have been asked when it is passing an axis passing through a point on the edge of the disk and also perpendicular to the disk. And here for the tangent, here now we are going to look for that tangent here for the axis of rotation. So my dear student, here Roman 1, using the perpendicular axis theorem, let us record the figure 1. Kwamba for any diameter, we are supposed to record the perpendicular axis theory and consider our figure Roman A. Now let us consider our figure Roman A. We say that moment of inertia through z axis must be equals to the sum of the moment of inertia along to the x-axis, then we add it by the moment of inertia along to the z to the y-axis. This is how our perpendicular axis theorem said. Kwamba tukiwa na moment of inertia through the center along to the z must be equal to the moment of inertia along to the x-axis, then we add it by the moment of inertia along to the y-axis. This is how our law said. So now let us imagine that The moment of inertia along to the z-axis must be equals to the moment of inertia along to the center. Kwa tutachukulia kuwa huyu moment of inertia along to the z-axis atakuwa ni sawasawa na moment of inertia along to the center, ambao kwenye uniform circular disk tumemsema ni sawasawa na half mr square. Kwa tutasubstitute sasa, kumbe Iz must be equals to Ic, which is equal to half mr square, where m represent the mass of the uniform circular disk, while r represent the radius of the uniform circular disk from the symmetry.